Assalamualaikum, a very good day to our lecturer and also fellow friends. So we are students from Determination of Organic Structure STKK 2522. We are going to present on the topic of fractional distillation. So our team members consist of HUSNA AISYAH, THANUSSHA PARAMESWARAN, SYARMIN ALYSSA, NUREEN IMAN ALIA, NATASYA, NURUL ASMIERA, me myself IRDINA BATRISYIA, DAYANG SYAKIRAH, FAZLIANA and Muhammad Hafiz.
Okay, Assalamualaikum and greetings everyone. Today, our group will be presenting about fractional distillation. Okay, so fractional distillation is basically used to separate a mixture of liquids that have different boiling points. But what is actually the difference between a simple distillation and a fractional distillation? Okay, a simple distillation is incapable of separating mixture if the boiling points of the components are close. That's why the insertion of a fractionating column is necessary in the case where we wanted to separate mixture of components that have close boiling points. A fractionating column contains indentations or a packing material with lots of surface area, like as we can see in the picture. The vapors will temporarily condense on this surface, and the heat of the distillation will allow the pools of liquid to vaporize again. One of the real-life examples of the use of fractional distillation is in the oil refineries where crude oil is separated into petrol, diesel, kerosene, and more.
Okay, so we move on to the theory, but first of all, fractional distillation is not a chemical reaction, it's a physical separation process. Okay, it works by separating components in a liquid mixture based on the difference in their boiling point. Okay, so this process relies on two scientific law. So first, Roots law states that the total vapor pressure of a liquid mixture depends on the vapor pressure of each component and their mole fractions. Okay, so to simplify, it actually means that each liquid in the mixture contributes to the total pressure depending on how much it presents and how easily it evaporates. Okay, and second, we have Dalton's law that states that the total pressure of a gas mixture is the sum of the partial pressure of each gas. Okay, so when we apply this into distillation, it means that each component's vapor contributes to the total vapor pressure above the liquid phase. Okay, so both laws explain how and why different components of a mixture can boil at different temperature that allows separation to occur in a fractional distillation column.
I will be talking about the types of fractional distillation equipment. So this is the laboratory scale equipment. After setting up the apparatus like in the diagram, a mixture of two miscible liquids, A and B, is taken where A has more volatility than substance B. So the solution is added into the distilling flask while the fractionating column is connected at the tip of the flask. So heat is applied, which increases the temperature slowly. The mixture will then start to boil and vapors then start rising in the flask. The vapors are from the volatile component A. The vapors then start moving through the fractionating column into the condenser where it is cooled down to form a liquid which is collected in the receiver. So throughout the process, vaporization and condensation take place repeatedly until the two mixtures are separated completely.
So, for this slide, I'll be focusing more on the general process of industrial scale fractional distillation rather than the table of parts fraction. So firstly, the crude oil that has been collected from deep under the ground will be heated in a chamber or a furnace until most of it has turned into a mixture of hot gases. Then, these hot gases will be passed into a fractioning column or the distillation tower, where the bottom part is very hot but gets cooler towards the top. So the idea is that this mixture of hot gases will rise up to the top of the column, but eventually, importantly, when they reach a region with a lower temperature than their own boiling point, they will start to condense the liquid. So lighter products like LPG and also petrol will be collected at the top and will flow out to the overhead outlet. Middle components like naphtha, paraffin, and also diesel, they will be drawn out to the side outlets at different heights. Meanwhile, heavier products like bitumen and also lubricant, they will settle at the bottom and also they will be drawn out to the bottom outlet.
Hi, so I'm going to talk about types of fractional distillation techniques. So to make it quickly, so we have four types of distillation, which is batch, continuous, azeotropic, and extractive. So for batch distillation, it's simple. You heat a fixed amount of liquid, collect the vapor, and stop when it's done. It's great for lab use and small batches. And for continuous distillation, works non-stop. You add feed continuously and remove product at the same time. It's more efficient and used in industry like oil refining. And for the azeotropic distillation, it's used when two liquid boils together, forming azeotropes like ethanol and water. We add third substance and called entrainer to break the azeotrope. for extractive distillation is similar to isotropic, but instead of forming a new mixture, we add a high boiling solvent to change how the liquid separates, like using ethylene glycol to separate ethanol from water. So in short, batch is flexible, more flexible, and for continuous, it's more efficient. For isotropic, we can add more third component, and for extractive, we can add a solvent. So the method that we can choose depends on our mixture and our goal. Alright, thank you.
Hello everyone, I'm THANUSSHA PARAMESWARAN, so I'm going to explain about the other types of fractional distillation technique. So the first one is vacuum distillation. Vacuum distillation is used to separate compounds that are in various liquids using a vacuum process. So it is used when compounds are difficult to separate due to having very high boiling points. A vacuum process is used to create a vapor pressure that impacts the other compounds that have lower vapor pressure to evaporate. So vacuum distillation may be used for liquids that become contaminated during the manufacturing or agricultural process and must be cleaned before being placed back into use or disposed of. So the second technique is steam distillation technique. Steam distillation technique is a separation process which purifies isolate temperature-sensitive materials such as natural aromatic compounds. So steam distillation also used for extraction of essential oils. It works by passing steam through a mixture, causing volatile compounds to vaporize at lower temperature and then condensing the vapor to separate the desired components. Steam distillation are widely used in petroleum refineries and also petrochemical plants.
Now, let's take a look at the key parameter for the fractional distillation. First, the pressure gradient. So, the temperature gradient will help in separation of the component based on their boiling point because the temperature will actually decrease as you go up the column. So, the second one is reflux ratio. If we take a look at the diagram, actually when the vapor rise and get condensed in the condenser, the condensed liquid will be split, which one part will return to the column as a reflux and the other part will goes out as a distillate, which is the product that we want to collect. So, that is a reflux ratio. So, a higher reflux ratio will improve separation. So the third one is pressure. By lowering the pressure, it will reduce the boiling point. This is useful especially if you want to separate heat sensitive component which may decompose at high temperature. Last one is theoretical place. So it refers to the number of stages where vapor and liquid reach equilibrium. More theoretical plates result in better separation and purification of the component because more plates mean more opportunities for the separation to occur.
Next, I'm going to explain on how the type of organic structure can be determined from fractional distillation. Experimental boiling temperature is compared with known boiling points to identify the type of compound and its purity. How do we know if this compound obtained is pure from the boiling points? Pure compounds will detail at a specific sharp boiling point, while impure substances may have a broader range of boiling points. Then, collected fractions can be further analyzed by using gas chromatography or spectroscopy to further confirm the identity of the organic compound obtained. For example, in the fractional distillation graph below, there are two fractions that was obtained from the fractional distillation experiment. So after comparison with known boiling points, it was known that the first fraction is cyclohexane, which has a boiling point of 80 degrees Celsius, while the second fraction is toluene, which has a boiling point of 110 degrees Celsius.
Next, advantages of fractional distillation. So the first one is efficient separation. So it effectively separates mixture of liquid with close boiling point, which simple distillation cannot do well. Next, high purity. So it can achieve high purity level for the separated substance, especially when a large number of theoretical plates are used in the distillation column. And then versatility. So it works for a wide range of substance from simple binary mixture to complex mixture with many components such as crude oil refining. After that, scalability. So fractional distillation can be used on both small, which is in lab, and large industrial scale. And then the continuous operation. So in industry, it can run continuously, making it efficient for processing large volume. Lastly, recyclability. So unwanted fraction can be reprocessed to improve yield and also the efficiency. So fractional distillation is a useful way to separate the liquid that boil at similar temperatures. It gives cleaner result, works well in lab and factories, run continuously in industry, and let us reuse leftover parts. So it's especially important in things like turning crude oil into a fuel. Next.
So I will explain the limitation of fractional distillation. So first one is the equipment complexity. It requires specialized apparatus like fractionating column, which can be complex and costly for large scale or high purity separation. Next is energy intensive. It requires a significant amount of energy to maintain the heat need for vaporization and condensation. And the last one is time consuming. The process can be slow especially when high purity is required or when dealing with large volumes. So
that will be all from our group. Thank you and Assalamualaikum.